This is SpaceTime Series 26, Episode 119, for broadcast on the 4th of October 2023. Coming up on SpaceTime, carbon discovered on Europa, NASA's Independent Review Board's report on the Mars Sample Return mission, and a new twist to the story of the great eruption of Eta Carinae. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered carbon dioxide, one of the key ingredients essential for life as we know it, on the surface of the Jovian ice moon Europa. The discovery, in data from NASA's Webb Space Telescope, suggested this carbon likely originated in the subsurface ocean beneath Europa's icy crust, and was not delivered by meteorites or other external sources. The discovery is vitally important because Jupiter's ice moon Europa is one of just a handful of worlds in our solar system that could potentially harbour conditions suitable for life. Previous research has shown that beneath its water-ice crust lies a salty liquid water ocean with a rocky seafloor. However, until now, scientists have not been able to confirm that this global subsurface ocean contains all the chemical ingredients needed for life, especially carbon. But astronomers using data from NASA's Webb Space Telescope have now identified carbon dioxide in a specific region on Europa's icy surface. And importantly, it was deposited there on a geologically recent timescale. The discovery, reported in 2 papers in the journal Science, has important implications for the potential habitability of Europa's oceans. The lead author of one of those 2 papers, Geronimo Villaluvia from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says that on Earth, life likes chemical diversity. The more diversity, the better. Earthlings are carbon-based life forms. And understanding the chemistry of Europa's oceans will help scientists determine whether it's hostile to life as we know it, or whether it might be a good place for life to evolve. The lead author of the second paper analysing these data, Samantha Trumbo from Cornell University, says the team believes it's observed evidence that the carbon seen on Europa's surface comes from the moon's subsurface ocean. She says that's not a trivial thing, because carbon is a biologically essential element. The new findings are all very timely, as NASA plans to launch its Europa Clipper spacecraft, which will perform dozens of close flybys of Europa to investigate whether it could have conditions suitable for life in October 2024. The Webb data shows that the carbon dioxide is mostly abundant in one region, an area known as Terra Regio, a geologically young region of generally resurfaced chaos terrain. An area containing large cracks, boulders and chunks of ice, looking like something's burst through from underneath. The crustal ice here has been disrupted, and there's likely been an exchange of material between the subsurface ocean and the icy surface. Previous observations using the Hubble Space Telescope have already shown evidence of ocean-derived salt in Terra Regio. Now, the detection of carbon dioxide, heavily concentrated in the same area, implies that the carbon probably has its origin also in the internal ocean. Scientists are now debating just how much Europa's oceans connect to its surface. Are there just a few fractures, or are there plumes all over the place? The important thing is these findings suggest that they may well be able to learn some very basic things about Europa's ocean's composition even before they need to attempt to drill down through kilometres of ice to get the full picture. The carbon dioxide was identified using data from the Integral Field Unit on Webb's near-infrared spectrograph. And we know it's fresh because carbon dioxide isn't stable on Europa's surface. Therefore, the scientists agree it must have been supplied on a geologically recent timescale, a conclusion bolstered by its concentration in a region of young terrain. Scientists are now trying to identify a plume of water vapour erupting from Europa's surface which could be the source of the carbon. Hubble reported tentative detections of plumes in 2013, 2016 and 2017. However, finding definitive proof has been difficult, and the new Webb data shows no evidence of plume activity. This is SpaceTime. Still to come, NASA's Independent Review Board reports on what's now needed for a Mars Sample Return mission, and a new twist in the story of the great eruption of Eta Carinae. All that and more still to come on SpaceTime. NASA has released its independent review board's Mars Sample Return Report. The space agency established the board back in May to evaluate the technical, cost and schedule plans of the mission prior to any final design. The board looked at current plans and goals, noting the scientific importance of the mission, but also expressing concerns over the mission's budget. The evaluation came up with 20 findings and 59 recommendations. Nicola Fox, NASA's Associate Administrator for Science, says the agency has plans for a robust Moon-to-Mars exploration approach. Mars is a rich destination for science discovery, and understanding the red planet supports the agency's Artemis program to ultimately send humans to the Martian surface. In response to the new report, NASA set up a review team. The team will make its recommendations by the second quarter of financial year 2024 regarding a path forward needed to keep the project within a balanced science program. Currently slated for around 2030, the joint NASA-European Space Agency mission will be highly complicated. It'll involve the launch of at least 2 rockets bound for the red planet. There's also the launch of a rocket from the surface of Mars, the first time a rocket's been launched from the surface of another planet, and there'll be an orbital rendezvous around Mars. Again, the first time there's been an orbital rendezvous around another planet. The current plans call for one of the Earth-launched rockets to carry a lander equipped with several Mars helicopters and rovers, as well as a small ascent rocket. The rovers and helicopters will be used to retrieve samples now being collected by NASA's Mars Perseverance rover as part of its ongoing exploration of Jezero crater and an ancient river delta which once flowed down into the crater carrying sediments from further upstream. The 6-wheeled car-sized Perseverance rover landed in Jezero back in February 2021, carrying the small experimental Ingenuity rotocopter. Jezero crater is a 45-kilometre wide impact crater located on the western edge of a flat plain called Cetus Planitia, which lies just north of the Martian equator. The landing site's about 3,700 kilometres from its sister rover Curiosity's landing site in Gale Crater. The samples being collected by Perseverance will be loaded into a special container in the Ascent rocket, which is mounted on the lander. The Ascent rocket will then be launched back into Mars orbit, where it will rendezvous and dock with the second rocket launched from Earth, which contains a return-to-Earth cruise stage. The sample container will then be transferred in orbit from the Ascent rocket to the cruise stage, which will then fly back to Earth. During its journey to Earth, the sample container will be transferred to a re-entry capsule, which will be jettisoned from the cruise stage upon approach to Earth. The re-entry stage will then re-enter the Earth's atmosphere and parachute down to the surface for collection by scientists. So this is a very complex mission. So far, Perseverance has collected samples in 22 out of its 43 sample tubes. These include 16 Martian rock and 2 Martian regolith samples and Martian atmospheric sample, as well as 3 witness tubes. Before launch, 5 of the 43 tubes were designated as witness tubes, and they were filled with materials which would capture particulates in the ambient Martian environment. 10 of the sample tubes have been left on Mars as a backup at a location known as Three Forks Sample Depot. 3 of the 5 witness tubes will also be left on the red planet. So, current plans call for just 30 of the tubes to be returned to Earth for study. The search for signs of past microbial life on Mars is the primary mission of the Perseverance rover, and the samples collected so far include a wide variety of different geological materials, including some which here on Earth do provide habitable environments suitable for life. This report from NASA TV.
Sample 1 is called Rubion. It's an atmospheric sample that we picked up from a place called Polygon Valley in the crater floor. Rubion is our one and only atmospheric sample. So in this case, the rock itself was old and altered, and it kind of crumbled as we were picking up the sample. And so when things don't go according to plan, we improvise, and we try to still get good science out of it. So in this case, now we have a capture of just the air that was around there, and that's also a valuable sample that we didn't have before. Learning about the atmosphere is important because that tells us what the elements and chemicals are that are in the air on Mars, which is really different than Earth, and it's different than Mars was in the past. And so we can do the same sorts of analyses that you could do on rocks to understand what makes up the air. What makes these two planets so similar but so different? The rocks are one part of the story, the air around the rocks is another part of the story. We decided to drop Rubion in our backup sample depot at Three Forks. There are not many ways to capture air from another planet, and we've got that.
Sample number 2 is named Montagnier. Sample number 3 is called Montagnac. This was our first pair of rock core samples collected from the Artuby Ridge region. We didn't anticipate finding igneous rocks on the crater floor. We thought we might be seeing things like lake sediments and sedimentary rocks for the most part. But instead, what we found were a lot of igneous rocks of a couple of different types. We found that in this rock were sort of pits and cavities and minerals that led us to believe that this rock had encountered quite a large amount of aqueous alteration, so interaction with groundwater, sometime after it was deposited. We're really excited about igneous rocks because once we have those rocks in laboratories here on Earth, we can use all sorts of laboratory techniques to understand the crystallization age. So it helps us get a very exact age for when these rocks were forming, which is a really useful thing that we've never been able to do before on Mars. Montagnac was drilled and sealed in the same sol, and the sample is slightly larger, so that is the sample that we kept on board the rover, whereas we placed the Montagnier sample in our Three Forks sample depot. To celebrate the collection of our first sample pair on the surface of Mars, we used the camera on the end of our robotic arm called Watson, and we took a celebration selfie.
Sample 4 is called Salette, and sample 5 is Coulette. We picked these both up in a region called South Zeta in the crater floor. These samples were interesting because they captured some of the diversity in terms of minerals that are in the rocks in the crater floor. So we saw signs that we think are from sulfates. We saw these little white crystals, and we think those are captured in the rocks that we collected. And those are evidence of alteration with water of the rocks that are on Mars. We also saw really strong signals of carbonates. And carbonates are exciting because they are also a record of water interaction with rocks and indications of pH neutral environments, which means that the environment was likely habitable a long time ago. We also saw signs of hydration, which means there's actually water trapped in these rocks. Out of these two samples, we decided to drop Coulette in our sample depot at Three Forks. Sulfates and carbonates and phosphates tell us more about the aqueous history of Mars, and so we were able to pick up that evidence in these samples. Sample 6 is called Robine, and sample 7 is Malay, and we got them from a rock called Isol in South Zeta in the crater floor. In order to learn more about a rock to decide if we actually want to pick up a sample there, we do what's called an abrasion patch. So we take a bit on our rover and we scrape off the surface of a rock. And so you can see some of the interior that's less altered by the exterior environment. In the abrasion patch associated with these cores, we saw this beautiful big sulfate crystal that looks exactly like a polar bear. And I remember it so strongly because we saw signals that look like sulfate, we saw signals that look like hydration, and it had another chemical that we think is either perchlorate or phosphate. These samples are interesting because they capture some of the diversity of minerals that we saw on the crater floor. And we saw things like white sulfate crystals. Those are exciting because on Earth, they can preserve signs of life for a really, really long time. For me as an astrobiologist, the other really exciting thing about this rock is that we saw multiple types of signals that are consistent with organics. And organics are the building blocks of life, and they're also signs of potential habitability in this environment. So maybe there are organics in the sulfate crystal that's in that polar bear in this rock. Out of this pair, we dropped Malay in the sample depot at Three Forks. That mix all together in just one 100 micron spot, which is a really, really small area. That was really unique and exciting about this rock.
Sample number 8 is called Hahoni. Sample number 9 is Atsa. This was a sample pair collected near our Octavia E. Butler landing site. This particular outcrop was interesting because we think it was slightly less altered and represents likely the most pristine of the igneous rocks that we've collected. Pristine refers to how fresh of a surface it is, essentially. And so some of the other rocks that we collected have evidence for interaction with groundwater. There's minerals in the rocks that form in the presence of water, like carbonates and sulfates and things like that. We didn't see that same type of evidence at this particular outcrop near our landing site, and so we think this pair of samples encountered less interaction with liquid water as some of the other samples that we collected. There were a couple of sols in between drilling and sealing for Otsa. So we dropped the Otsa sample in our Three Forks sample depot. This sample pair is from the Maz Formation. So we collected a couple of pairs from the Eta Formation. We collected one from the Maz Formation. And then as we were finishing up our crater floor campaign, we wanted to collect one more sample pair to represent the Maz Formation. So we have roughly the same number of samples from each of the igneous formations that we've encountered. And so this was a very valuable sample pair to collect.
Sample 10 is called Swift Run, and sample 11 is Skyland, and we got them from a rock called Skinner Ridge in the Delta Front. These samples are really interesting because they're the first ones from the Delta Front. So we're out of the crater floor, we're into the Delta Front, and what made this rock particularly interesting is carbonate was everywhere. This was like a carbonate rock. And so in a lot of the other rocks we looked at previously, there was variation across even a small area. There were all of these different minerals sort of clustered together. In this rock, you could see that there was textural variation, so you could see different grains, but this carbonate signal was really, really strong. And carbonate is that mineral that shows evidence of water alteration of rocks, especially in a possibly habitable environment. Out of this pair, we dropped Skyland at our Three Forks sample depot. Deltas on Earth are really good places for habitability and astrobiology studies because they can preserve signs of life for a really long time, and they're usually hotbeds of life activity. And carbonate minerals, which is something that we saw really strongly in these samples, they can preserve organics and signs of life for a very long time.
Sample number 12 is called Hazeltop. Sample number 13 is called Bear Wallow. This was a pair of samples collected from the Wildcat Ridge outcrop at the Delta Front. This sample pair represents a fine-grained mudstone. It's a really fine-grained sedimentary rock that was deposited in an ancient lake. Because of the fine grain size of this rock, we think it has a higher potential to preserve signs of ancient life. Hazeltop was my favorite because if you look at the images looking inside the sample tube from the core sample, you can actually see a little mineral vein in the rock. The rocks will fracture, and then water will pass through them and leave behind mineral veins in the rocks. And so you can actually see evidence of a small little mineral vein, which is really neat. We also think that we cored into a concretion, which is direct evidence of ancient interaction with water on Mars. Hazeltop is actually a little bit smaller than Bear Wallow, but because of the potential for the concretions and the vein in the Hazeltop sample, we decided to keep that one on board, and instead we dropped the Bear Wallow sample in the Three Forks sample depot. It's got a lot of good stuff in there, and I'm really excited about that sample.
Sample 14 is called Shuyak, and sample 15 is Magik, and we got them from a rock called Amalek in the Delta Front. So Amalek was a really interesting rock because it looked like a relatively fine-grained rock that had clay. And on Earth, fine grain and clay are sort of thought of as the holy grail for where you would find biosignatures, because there's a lot of good evidence that it preserves signs of life for a really long time.
These sedimentary rock samples that were collected from the Delta Front, these are the rocks that we came to Jezero Crater to collect because they represent lake environments where we have fine-grained mudstone and siltstone deposits where we're hoping to find signs of organic molecules and potential biosignatures. We're looking for signs of ancient life on Mars, and these are the rocks that we think have the best potential to preserve those signs.
Out of this pair, we dropped Magik at our Three Forks sample depot.
We're really excited about this sample pair because these represent more samples of fine-grained siltstone and mudstone deposits.
On Earth, if you go to a fine-grained clay-bearing rock, you'd be like, wow, amazing, perfect, great. This is where I'm going to find signs of life. And if that isn't true on Mars, this rock will be a really good test. Sample 16 is called Kukaklek, and we collected it from a rock called Hidden Harbor in the Delta Front. This sample is interesting because we started to see diversity in the textures associated with sulfate minerals. So there was a lot of sulfate in these samples, but they didn't look the same in every case, meaning that these samples captured the diversity in this type of mineral on Mars. Seeing different textures and colors associated with similar minerals in one rock can indicate a variety of different things. One possibility is there were different fluid events. So we know that sulfate is associated with water, and we saw hydration signals in this rock as well, but we saw multiple different kinds. So does that mean water interacted with this rock multiple times? And what happened in each of those times? This sample is part of the collection carried by the rover that will hopefully come to Earth.
Sample number 17 is called Atmo Mountain. Sample number 18 is called Crosswind Lake. This pair of samples was collected from the Observation Mountain location near the Delta Front. This was our first pair of regolith samples, which is very different from the rock core samples that we were collecting up until this point. Regolith essentially just means loose material and represent a range of grain sizes. The scientists on the team refer to it as a jewelry box because you have all of this different material all in one sample. We have sand, pebbles, dust, so we can get a really good sense for what this material is made out of, where it came from.
And what's exciting about these is that they can represent a much broader region. So most of the rocks that we observe have been in that place for at least some amount of time. Dust can have been transported way more frequently, so we might be getting sort of a window out beyond just Observation Mountain or even just the Delta Front.
And it also helps us understand some context for eventual human exploration of Mars, because we want to know how the really fine-grained materials like dust interact with spacecraft and material, and also with astronauts that are exploring the surface. We decided to drop the Crosswind Lake sample in the Three Forks Sample Depot. This was our last paired sample before Perseverance dropped 10 tubes in the sample depot at Three Forks. So from here on out, we're going to be collecting single samples at each of our sampling locations.
There's value in observing something where it's been for a long time, but there's also value in observing something that's transported a lot. Because basically, we can't get everywhere on this traverse. So if we can pick samples that have been a lot more places, we can get like a bigger diversity easier.
Sample 19 is called Melon. It was collected from the Berea outcrop from the Upper Fan campaign. This particular sample, Melon, is unique because it is the first sample of the Upper Fan campaign. It's unique also because it represents deposition in an ancient river versus an ancient lake deposits like we were seeing lower down at the Delta Front campaign.
This sample is interesting because it has a lot of carbonate, which was exciting because we're seeing that story continued across the different regions in Jezero Crater. So we saw some variations in the crater floor, then in the Delta Front, and now in the Upper Fan. This can start to tell us about a flow that may have happened, or how widespread the water was, or if the crater was filled multiple times with water, like it was filled and then dried and filled and then dried. How would that show up in terms of diversity and region within the crater?
This rock was deposited from flowing rivers that carried material from outside the crater into the crater and deposited them along the Upper Fan here. And so we're interested in learning more about where these rocks came from. And because these were carried in from river channels from outside Jezero, this is the perfect sample to answer those questions.
This sample is part of the collection on the rover that will hopefully be brought back to Earth.
And in that report from NASA TV, we heard from JPL Mars Perseverance rover astrobiologist Sandana Sharma and Rachel Kronyak from JPL Mars Perseverance rover Science Operations. This is SpaceTime. Still to come, a new twist to the story of the giant eruption of Eta Carinae. And later in the science report, it's now confirmed that 2023 was Earth's hottest Northern Hemisphere summer since global records began. All that and more still to come on SpaceTime. Astronomers have combined 20 years' worth of data on one of the brightest binary star systems in the sky, Eta Carinae, to uncover important new details about a massive eruption witnessed on Earth in the mid-19th century. The new findings, reported in the Astrophysical Journal, are based on observations taken by NASA's Earth-orbiting Chandra X-ray telescope. Astronomers used the Chandra observations, along with data from ESA's XMM Newton X-ray Space Telescope, to glean new, never-before-seen details about a massive stellar eruption 180 years ago, which is continuing to expand into space today at speeds of over 7 million kilometres an hour. Located some 7,500 light-years away between the constellations Canopus and the Southern Cross in Carinae in the Trumpet 16 open star cluster, Eta Carinae is a ticking time bomb. The two massive stars are undergoing a violent final phase of their existence before exploding as spectacular core collapse supernovae. The primary star is estimated to be somewhere between 150 and 200 times the mass of our Sun. It's 5 million times as luminous as the Sun. It has 800 times the Sun's radius and a surface temperature of some 32,500 Kelvin. The companion star, although smaller than the primary at just 80 solar masses, 20 times the Sun's radius, is even hotter, with a surface temperature of around 37,200 Kelvin. These two massive spectral type O blue stars orbit each other every 5.54 Earth years, cocooned deep inside a gigantic twin-lobed cloud of thick gas and dust known as the Homunculus Nebula, a bipolar emission and reflection nebulae. The nebula was created when Eta Carinae underwent a spectacular eruption starting in 1837. Known as the Great Eruption, it eventually reached its peak in 1843, when it was one of the brightest objects in the night sky, before gradually fading away again by 1856. Both Eta Carinae and its surrounding shroud of dust generate huge amounts of infrared radiation, making it the brightest infrared source in the sky. Eta Carinae underwent another slightly smaller eruption in 1892, and it's been steadily brightening again since about 1940. During the Great Eruption in 1843, Eta Carinae ejected between 10 and 45 times the mass of the Sun. With both stars now reaching the ends of their lives on the main sequence and expected to go supernova virtually any day now in astronomical terms, scientists are keeping a close watch. But they won't have to look very hard, because when it does go supernova, Eta Carinae will be clearly visible even in daylight, and may even become brighter than the Moon for several months on end. What the new research has been doing is studying a bright ring of X-rays around the Homunculus Nebula, which were first discovered about 50 years ago and studied in previous Chandra work. This new data uncovered by Chandra is revealing important new hints about Eta Carinae's violet history, including the rapid expansion of the ring and a previously unknown faint shell of X-rays just outside it. The study's lead author, Michael Kokorin from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says this faint X-ray shell could be a blast wave from the Great Eruption of the 1840s. And if so, it tells an important part of Eta Carinae's backstory that would otherwise not have been known. Now, because this newly discovered outer X-ray shell has a similar shape and orientation to the Homunculus Nebula, Kokorin and colleagues think both structures probably have a common origin. The idea that material was blasted away from Eta Carinae well before the 1843 Great Eruption, sometime between 1200 and 1800, is based on the motion of clumps of gas previously seen in data from NASA's Hubble Space Telescope. Later, the fast blast wave from the Great Eruption tore through space, colliding and heating the earlier clumps to millions of degrees, creating the bright X-ray ring. Now, that blast wave has now travelled well beyond the bright ring. The shape of the faint X-ray shell shows that the faint shell, the Homunculus Nebula itself, and the bright inner ring likely all came from eruptions from the star system. With XMM Newton, researchers saw that the X-ray brightness of Eta Carinae had faded with time, and that agrees with previous observations of the system obtained with NASA's Neutron Star Interior Composition Explorer telescope mounted on the International Space Station. The authors applied a sample model in order to estimate how bright Eta Carinae would have been in X-rays at the time of that great eruption, and they combined this with the speed of the material they determined from these new observations. This allowed them to estimate how quickly the high-speed gas was being ejected. The authors then combined this information with estimates of how much gas was ejected to determine that the great eruption likely consisted of two explosions. There was a first quick ejection of a small amount of fast low-density gas, which produced the X-ray blast wave. This was then followed by the slower ejection of dense gas that would eventually form the Homunculus Nebula. A team led by Nathan Smith from the University of Arizona, one of the co-authors of the new X-ray study, had previously suggested that the Great Eruption was caused by the merger of two stars in what was originally a triple-star system. Now, this would also explain the ring-like structure seen in X-rays, because it would have caused the material to be ejected in a flat plane. Smith says the story of Eta Carinae just keeps getting more interesting. All the evidence is suggesting that Eta Carinae survived a very powerful explosion that would normally obliterate a star. But the ticking time bomb of Eta Carinae keeps ticking away for the next big and possibly final eruption. We'll keep you informed. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The Northern Hemisphere's summer of 2023 has now officially been confirmed as Earth's hottest since global records began in 1880. Scientists with NASA's Goddard Institute for Space Studies found that the months of June, July and August combined were 0.23 degrees Celsius warmer than any other Northern Hemisphere summer in NASA's records, and 1.2 degrees Celsius warmer than the average summer between 1951 and 1980. In fact, August alone was 1.2 degrees Celsius warmer than average. The new records came as exceptional heat swept across much of the world, exasperating deadly wildfires in Canada and Hawaii, and triggering searing heat waves in South America, Japan, Europe and the US, while also likely contributing to severe rainfall in Italy, Greece and Central Europe. NASA assembles its temperature records from surface air temperature data, acquired by tens of thousands of meteorological stations, as well as sea surface temperature data from ship and buoy-based instruments. The raw data is then analysed to account for varied spacing and temperature stations around the globe and for urban heating effects that could skew calculations. The record-setting summer continues a long-term trend of warming. Scientific observations and analysis made over decades by NASA, the National Oceanographic and Atmospheric Administration NOAA, and other international institutions have shown that the warming has been driven primarily by human-caused greenhouse gas emissions. At the same time, natural El Niño events in the Pacific are pumping extra warmth into the global atmosphere, and this often correlates with the warmest years on record. A new study has found that jellyfish can be trained to spot and dodge obstacles despite their lack of a central brain. It was previously thought that advanced learning might not be possible without a centralized brain. So the researchers tested this theory by putting Caribbean box jellyfish into a tank decorated so as to make one of the walls look further away than it was. A report in the journal Current Biology shows that over just 7.5 minutes, the jellyfish were able to reduce the amount of times they bumped into the wall by 50%. Australia has announced that it will purchase a fourth MQ-4C Triton high-altitude surveillance drone from Northrop Grumman. The news came as Northrop Grumman were also awarded the maintenance contract to keep the sophisticated multi-role intelligence-gathering unmanned aircraft operational. The squadron will be operated by pilots at a ground station at the Canberra Air Force Base in Adelaide's north, with the aircraft themselves flying out of the Tyndall Air Base near Katherine in the Northern Territory. The Triton is intended to provide real-time intelligence, surveillance and reconnaissance missions over oceans and coastal regions, and to complement the Air Force's Boeing P-8 Poseidon maritime patrol aircraft. The Tritons will help Australia meet its security needs by providing maritime monitoring and sovereign surveillance of the sea lanes of the Indo-Pacific. The Australian Tritons are progressing as planned through the construction schedules, with the first test flight slated for later this year at Northrop Grumman's Palmdale Aircraft Integration Centre in California. The first of the jet-powered aircraft should arrive in Australia next year. Once operational, Australian and US Tritons will share their data, providing a critical ability in one of the world's most strategically important regions. The Tritons are based on the earlier RQ-4 Global Hawk, but they feature reinforcements to the airframe and wing, de-icing systems and lightning protection. This allows the aircraft to descend through cloud layers in order to gain a closer view of ships and other targets at sea. The sensor suites will help gather details on ships, including their speed, location and classification. It's been another big week for artificial intelligence advances. And now with the latest happenings, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
So OpenAI, the company behind ChatGPT, has announced that ChatGPT Plus in a couple of weeks will have an update where it can speak to you and listen to what you're saying. It can see, so you can take photographs and, for example, show it maths equations that you might need help with, or you might want to help your children's education with, or you might have some code that you've been writing about on a whiteboard with your fellow developers, and then ChatGPT can write the code for you. So it can see, it can hear, and it can speak. And this will come to regular ChatGPT users in a few weeks as well, but 2 weeks' time for those who are paying US $20 per month. OpenAI has been receiving a lot of competition. there's a company called Anthropic, which has received a $4 billion investment from Amazon. And Anthropic does the Claude 2 GPT, which is seen as quite a competitor to ChatGPT 4.
All right.
So there's lots and lots of things happening out there. Of course, we also have Microsoft, who launched their Windows 11 with the Copilot built in. Now, Microsoft invested $10 billion into OpenAI. So it's like they more or less own half of it, or a part of it anyway. And they've been using ChatGPT's technology inside of Windows. And so that is now the first operating system to have a built-in AI. Even though you could get plugins for Mac OS and all sorts of plugins, this is the first time it's native. And I'm sure Microsoft will at some point allow you to let its Bing AI to see, to hear, and to speak back to you as well, because it's only natural. And somebody actually did the same demonstrations that OpenAI did with its seeing, hearing, and speaking. And Bard AI on Google can do the same things too. So we're really entering an era of AI that is just going at a super fast pace. And in fact, just to finish off on this topic, we have Anthropic CEO and co-founder Dario Amodei saying at the recent TechCrunch Disrupt conference that the last 10 years, he said, this has been a remarkable increase in the scale that we've used to train neural nets, and we keep scaling them up, and they keep working better and better. And basically says that what we see in the next 2 or 3 or 4 years is going to make what we've seen so far pale into insignificance.
A brave new world.
The only one that is not making a big song and dance about it in terms of saying AI is Apple. But a lot of the things they're doing in the background are all AI driven as well. So yeah, this is the beginning stages. We'll one day reminisce about a world where we didn't have AI, just like we wonder how our parents and grandparents existed without the modern smartphones that we live by today.
Now, speaking of Apple, Mac's got new software out.
Yeah, so Mac OS 14 Sonoma has finally launched. So this is on the same day that Windows 11 with its AI Copilot launched. We had Mac OS launching. There's a number of interesting features, 5 of them to really stand out. This new game mode, it prioritizes CPU and GPU to really give the Mac OS the ability to compete on a level playing field with the PCs and the consoles that have always been known for gaming. Now, Apple has got a really big gaming head start on its smartphones and tablets. So it's time for the Mac to shine, and this is its era. We also have desktop widgets. Now, we've seen widgets on Androids and on iPhones for a while, but the widgets now on the desktop can also be interacted with. So that's an interesting little extra bit of information that allows you to just at a glance see your upcoming emails, appointments, and other weather and other things that you are used to on your phone. If you're using AirPods, it'll now switch even more seamlessly and more quickly between iPhone, iPad, and Mac. Big upgrades to the Notes program. You can start something in Notes, which is like text editor on steroids, and you can then finish it in Pages, which is Apple's version of Word. And also the video conferencing. If you're talking in Zoom or FaceTime, if you have a presentation, you can actually have that appearing behind you, and you can be in front of it as though there was a big green screen in front of you. And so that's just going to make presentations look a bit more professional.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.